In this video, I'm going to explain how the CAN adapter works. So the CAN adapter is a USB dongle or stick with CAN transceiver and CAN MAC layer it can be used for car and vehicle application like OBD or the onboard vehicle diagnostics to query the car for different data like the vehicle speed, the engine RPM, the temperature, and so on. So we are going to apply this today and see how it works. So before we do that, let's go first and set up the hardware, and then we'll get back to the software and see how it works. This is a CAN adapter board. You see it has a CAN transceiver. It has all the CAN functionality inside the STM32F072 microcontroller, and now we are going to use it for that demo. This is an OBD cable from 5G Hub. It's a special cable with an OBD connector on one side, and you have free floating wires on the other side. And then this is like the car OBD. It's an emulator for the car. So it's used it can make life easy by emulating the car emulator exactly, and it does emulate all the functionality in car and vehicle. So the first thing is to hook these wires into the board. So I know for sure the green wire is the CAN high, so I put it into the board, and I know the white wire is the CAN low, so I connect it to the board, and then I know the black is the ground signal, so I put the ground signal to the ground pin on the board here, and then eventually I will connect the emulator to the cable like this. So now the cable is connected to the car. Now the next step, I will plug into the board into my USB connector. So now the CAN adapter is hooked up to my PC. You see the LED is turned on, meaning there is a power, and you see all the cable now, the green and white color. The green and white cable is connected to CAN high and CAN low signal, while the black color is connected to the ground. Now let's go to the desktop and see now how can we transmit the CAN message and receive the CAN message from the OBD emulator or from the car. So simply you can download this software which is done as an Arduino from our website, and after it follow the normal Arduino procedure. So choose our Arduino board STM32F072, and then you can go through the application. The important thing is that we are using it also with another OBD emulator. Here you can see the OBD emulator. It's a car emulator. It's an OBD car emulator. You can set all the value here and keep testing with it. So we are using it with that. So for example, I'm going to set the adapter to work at CAN speed of 500 kilobit per second. And you can see here, this is highlighted here by CAN init. So you initialize your CAN adapter by the speed you work. On the OBD car or the car OBD, there is different CAN speed, so you can choose CAN 500 kilobit per second or 250 or 500 with 29 bit, which is extended CAN ID. So in our case, and for this scenario today, we're going to use the CAN speed 500 kilobit per second and 11 bit. So this is simply the setup of the application, and then let's assume I wanna query the car. For example, I wanna send some command to the car to query which OBD standard this vehicle conform to. So this is the CAN command or OBD command 01C. 01 is a service ID and 1C is the BID. And then I can continue query the car for different data, like what also the BID supported, which reading I can read from the car, And then if I find it support, for example, query the engine coolant, so I can send another command to query the engine coolant temperature. I can send another one to query the engine speed in RPM. I can send another one to query the vehicle speed in km/h. I can send another one to, for example, read the mass airflow reading. And finally, I can read throttle position. So you can send, this is an example. This is only the 5 reading that are most important for mini OBD application to read, but you can add as many query as you like for example, query the error code in the car, maybe the fuel level, and other many data that exist in the OBD. So now I go and compile this sketch here and then upload it. So I try to compile first. And then you can press upload to upload it to the hardware board, and then we are ready to go. So let's see what will display here on the serial monitor. So now I have the board. I will plug it into my computer USB just to power it on, and then let's see what data come out of it. So you can see here it start to display the data. So let's go one by one over it and see how it works exactly. So first of all, I'm using the bitrate 4, which is 500 kilobit per second. CAN initialization went smooth, and it's okay, successful. So first I will send the first OBD command, OBD standard this vehicle confirmed to, and you see this is the data, this is the CAN data coming from the car or from the vehicle. It comes with a standard ID header 7E8, and the data is like this hexadecimal value. Now if we encode these data according to the OBD specification, you will send this data mean the car supporting OBD2 as defined by the CARB. So this is when we query which OBD standard this vehicle confirmed. Now I continue and query the car, what BID or what service I can query the car. So it responds by this CAN data as well, and it responds back by all hexadecimal if we mean it support all BID services. Great. So now let's continue and query the car for the engine coolant temperature, for example. And you can see it returns some CAN data, and then we decode it as it's the engine coolant temperature as 90. So let's compare this to the OBD emulator and see is the car set really for that value. And you see here indeed on the OBD emulator the engine coolant temperature is set to 90 Celsius, which is exactly is returned by transmitted by the CAN adapter and received by the CAN adapter from the OBD device. Now let's go to the engine speed. Again, we send the engine speed, we receive some CAN data here. When we decode it, it says the vehicle speed in RPM is 1000 RPM. So let's go and see if this is indeed the case. And yes, true, you see the engine RPM is set to 1000 RPM, which means that this car indeed, the CAN adapter indeed transmit the right query and receive some CAN data, which when decoded, it results in the actual correct reading, which is 1000 RPM. So let's go to vehicle speed and query the vehicle speed in km/h, and you can see this is a CAN data returned by the car, and then the display value is 50. So let's go and see if really this is the case with vehicle speed. And you see here vehicle speed on the OBD simulator is set to 50, which is indeed read by the CAN adapter. So let's now go to mass airflow, and again when we send the command we receive this data from the car or the OBD emulator, and it shows a reading of 80. So let's see where is the mass airflow exist. Here you see mass airflow, and its reading is 80%, which is indeed returned by the 80%. The final reading we are interested in is the throttle position, and we want to see, okay, what is the throttle position of the car, and this is the data returned by the car or the OBD emulator, and its reading is 20. So let's see whether this is match with the car emulator. So here you see the throttle position is indeed set to 20%, which is transmitted. I mean, this data is transmitted correctly by the CAN adapter and received correctly by the CAN adapter. So that's the CAN adapter with the OBD application for today, and we're going to cover more uses and feature of the CAN adapter with other application in coming video. Thank you.